Alright, welcome to chapter 8. So chapter 8 will be talking about some real life application of trigo. For 8.1, we will be talking mainly about bearing. So what is a bearing? So to put it to simple term, bearing is actually just an angle measured in the clockwise direction from the north. Okay, so it is commonly shown in 3 digits and a decimal if it's needed. So for example, let's say if the bearing is 7 degrees, okay, we will write it in the form of 0, 0, 7. Okay, if let's say there is a decimal and it's 9.5 degree, we will put it as 009.5 degree. So if it's 1 digit, you have to add the 2 zeros at the front. Let's say if it's 2 digit, if it's 83 degree, it will be 083 degree. And then if it's 3 digit, you can just write the number as itself. So for example, if it's 255.2, I will just put 255.2 degree. Okay, so what are the general steps to solve bearing question? So first, we need to find out where the bearing is from. Yeah, this is very important. So this is where most of you will make your mistake. So read the question carefully, find out where the bearing is from. Only after that, then you draw the north line. Okay, this step is also important. I will elaborate later. Next, from the north line, go clockwise until you reach the bearing that you are looking for. Okay, so for example, let's say I want to find the bearing of B from A. So this is how the question will normally put. So first thing you need to know is where is it from. The question is asking from A. So I will go to the point A. I will just shade it a little bit. Next, step 2. I want to find the north line. Okay, so I'll just draw the north line. So if the question never state, north is always upwards. Okay, it's straight ahead. Okay, so this is my north line in red color. And then I will go clockwise to the bearing you're looking for. So in this case, I am looking for B. So from the north line, I will draw until I reach B. Okay, so in this case, it will be 135 degree. Okay, so just now I mentioned that we have to draw the north line, which is a little bit weird or redundant because sometimes there is already a line over there. So why is it important? Okay, so there are some questions where they provide you with a compass and show that the north is in a different direction. So in this case, we can see that our north is pointing towards the right side. So if our north is pointing towards right side, we can see that when I draw the north line, it will be towards the right, and my bearing of B from A becomes 45 degree instead. So it becomes 045. Can see how it changes? Okay, so before we move on, let me just do a quick screenshot so that you can easily refer to later. Okay, so I'll put the steps at the top left so we can always refer to. After a while, I will probably remove it. So moving on to the questions. Moving on to the worksheet. A bearing is a angle of an object relation to blah 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 in the clockwise direction. Okay, it is the same thing as what I went through just now. Then this one will be the north line. Okay, so what do you notice about bearing? Bearing must be written in 3 digits. Okay, so this one I already went through, so I'm just gonna skip this part. I just fill it up for those who missed the lesson or missed what Mr. Chiang said. Okay, so moving on to example 1. Example 1, they want to find the bearing of B from A. So the first thing I will do is from A, I will shade generally from A. The next step, I have to draw my north line. So this is just to remind me that north is facing up. And then I want to find the bearing of B. Okay, so from the north line, I'll go clockwise. Okay, I see that it is actually very simple. It is just 30 degrees. Okay, but since I am finding the bearing, I cannot just leave it as 30 degree. I have to write it as 030. Okay, moving on to B. I want to find the bearing of A from B. Okay, always first step, find out where it is from. Then I will shade it. I will draw my north line. Okay, so afterwards I will go clockwise. Okay, clockwise, I realize it is this angle. So if you want to calculate directly like that, it's slightly harder. What I would recommend is I extend this line a bit. Now, do you see that actually both my north line are parallel to each other? So I can do something like this. Okay, I can use my alternate angle, which is the property of the parallel line. Okay, so now using alternate angle, I can see that from this blue line to here, it is actually 30 degree. Okay, and then from my north to this vertical line is actually just 180 degree. So now it becomes a lot easier. I can just have 180 degree plus my 30 degree, and this will give me 210 degree. Next question. So I'm trying to find the bearing of Y from X. Same thing, I highlight X. I go to point X. I know my north is straight up. Okay, I want to find the bearing of Y. So I will go clockwise direction. Okay, so in this case, it will be 180 degree minus 53.2 degree, which will give me 146.8 degree. Okay, part B, I want to find bearing of X from Y. So from Y, I draw a north line and I go one full round all the way until I find the X. Okay, same thing. What I can do is I can use my alternate angle. So do you see that there is a Z over here? Okay, using this alternate angle, I know that this is also 53.2 degree. So now I can just take 360 degree minus 53.2 degree, and this will give me 306.8 degree. Moving on to example 2. So the diagram shows a relative position of PQR. Find the bearing of Q from P. Okay, first thing, I will take note where it is from. Okay, so now I know it's from P. I have my north line. I want to find Q. Okay, so actually it is already given straight away. It is 120 degree. Okay. Next, I want to find bearing of P from Q. Say same thing. Step 1, go to Q. Then I draw my north line and I'll go clockwise. Okay. So same thing, I like to use alternate angle. So over here, I will extend down a little bit. And from here, I can actually use my alternate angle. Okay, the one in green color. I will know that over here, let me draw in green color instead. So from here to here, it will be 120 degree. Okay, then my first part, from north to the blue color line, it is 180 degree. So when I add them up together, be 120 plus 180 degree, it will be equals to 300 degree. Okay, you can use interior angle and all those, but I prefer to use alternate angle because I don't have to do any calculation. So it reduces the chance of me getting any careless mistake. Okay, so moving on, part C. I want to find the bearing of R from P. Okay, same thing from P. I already have my north line. I will use blue color so I don't confuse with the A and B. Okay, from my north line, I will draw one circle all the way until I reach R. Okay, do you see that I can split it into two parts? First, I have my 180 degree. Okay, 180 degree. Then I have my 34.9 degree. So now I can just take 180 degree plus 34.9 degree. This will give me 214.9 degree. Okay, bearing of P from R. Okay, so I'll go to R. I will draw my north line and then I'll go clockwise. Same steps. So over here, I realize I can form my Z shape. Okay, for me to use alternate angle. So I know that this is actually also 34.9 degrees. Okay, so the bearing will be 034.9. Okay, so take note, you have to add an extra 0 because it is just 2 digit. Okay, next question. Calculate the bearing of E from D. Same thing. I will always highlight from where just to remind myself. And then I'll go to D. I'll draw my north line. Okay. I want to find the bearing of E. So it will just be over here. So this one very simple. Take 180 degree cos angle on a straight line minus 45 degree. I will get an answer of 135 degree. Okay, for those who don't know how I get this, it is just adjacent angles on a straight line. Okay, part B. Calculate the distance of DF. Okay, so where is DF? So DF is this one, highlighted in green. Okay, so over here, actually, it has nothing to do with bearing. So you have to go back to your previous topic where you learn about sine rule or cosine rule. The reason why I cannot use basic Tokaso because this is not a right angle triangle. So I know I have to use either a sine rule or cosine rule. Okay, let me do a little recap on the side first. Okay, sine rule is something like this. So I have A over sine A equals to P over sine P. Okay, so the sides and the corresponding angle will be in one fraction. Okay, cosine rule. Okay, cosine rule, the formula for it is C square equals to a square plus b square minus 2ab cosine c. So how do I know which rule to use? Okay, so when we look at the formula, I see that for me to use sine rule, I need to either have two sides plus one angle, or I need to know one side plus two angles. Okay, only when I have either one of these conditions, then I can use sine rule, because I can only find one of the four unknown. Okay, next, cosine rule. When I look at the formula, I need to know, for me to even use the formula, I need to know two sides plus one angle, or I need to know three different sides before I can use this formula. So what do I mean? So let's look at cosine rule. For me to use this formula, let's say I have three sides. So I have C, I have A, I have B. Only when I have these three, then I can find my C. Okay, my angle C. If let's say I have two sides, let's say I have A, I have B, and I have an angle, okay, then I can find my C, my big C square over here. Okay, but if let's say I do not have any of this condition, means I probably can't really use my cosine rule. Okay, so same thing for sine rule. Only when I have, let's say, two sides, so I have both A, I have big B, okay, and then I have one of the angle, I can find my sine A. Okay, so based on this, it's just a small recap. So now you know when I can use which of the rule. So now going back to the question, I have two angles and I have one side. So I have two angle plus one side. Okay, the only one that I can use here is actually my sine rule. Okay, not alternatively. So actually in a triangle, since I know I have two angles, I also can find my last angle. Okay, but in this case, it doesn't matter because I don't have to use this last angle. Okay, but either way, if let's say I have two angle and two side, I can still use my sine rule, and I still wouldn't be using my cosine rule. Okay, so now I will proceed to find df. So df, I will always put my unknown at the top left. Okay, I'll always put it in the numerator, sorry. So it'll be easier for me to solve later. So df is the one in green. The corresponding angle is the one across, so is 67. So sine 67 equals to 2.3 over its corresponding angle. In this case, it will be sine 45. Okay, so now since my unknown is already at the top, I just have to do one step, which is bring my denominator to the other side. Okay, so for those who are not fast enough, you can just multiply both sides by sine 67. If not, I will just bring it over. So what I will get is 2.3 multiplied by sine 67 over sine 45. Okay, and this will give me a length of 2.99 meters. Okay, give me a moment, I'll check if this is exact answer. Okay, actually this is a 2.994. 2.99411, and then I round off to 2.99 meter. Okay. Okay, moving on to part C. So now I want to find the area of DEF. So just a recap. Area of triangle equals to half AB sine C. Okay, in this case, I will use my DF. So I highlight green. And then my other length that I have is FE. So I put it in purple. And then sine C. Yeah, is this small angle here, which I don't have yet, but I can find it easily. So first step, I'll find my angle first. Okay. So to find the angle, just 180 degree minus 45 degree minus 67 degree. I will get 68 degree. Okay, so this is just angle sum in triangle. Okay, so now I have AB sine C. I can just find my area of triangle DEF. I substitute in half A. Here be my answer from the previous part, 2.99411. Use the exact value. Okay, B will be 2.3, followed by sine 68 degree. Okay, I type this into calculator. Okay, this will give me a value of 3.1925. I round off to 3SF, 3.19. And the unit is meter square. Okay. So just to help you color code it a little bit. Okay. So 2.994 is my green color line. My purple line is 2.3. And my angle is 68 degree. Okay, moving on to the next example. So I'll go through example 4. Okay, XYZ is a triangular plot of land. It is given that XY equals to 15. Okay, everything is already shown in the diagram. So calculate the bearing of Z from X. So first thing, I know it is from X. Okay, so I go to X, slowly go down. Okay, this is the angle that I want to find. Okay, but before I can find this angle, I need to know this angle in blue color first. But the question only gave me 3 sides with no angle. So what do I do? Okay, let me remove this pin. I will go back to my condition that I have written above. So let me screenshot this. Okay. So I'll screenshot this. I'll pin it. Yeah, I'll put it at the top left. Okay. So now I have 3 sides. Okay, and the only one that I can use here is my cosine rule. So I will treat this angle that I want to find as C. Okay, so which means my capital C will be 21 degree. Sorry, it will be 21 meter. A and B can be either one. It doesn't matter. So I'll just put this as A, 15 as A, and 24 as my B. Okay, I plug it into the formula. So let me write down the formula first. Okay, c square equals to a square plus b square minus 2ab cosine c. Okay, so let me shift this formula around first before I bring in any number. Okay, once I bring in the number, I have to write more things. So I'll just use this formula first. Okay, the first step that I'll do, okay, either you remember the other formula to find the angle, or you can start with this, and then you slowly move things around. Okay, for me, I am not very good at memorizing stuff, so I always remember one formula, and then I manipulate the formula. In this case, I will bring my whole minus 2ab cosine c to the other side. I'll bring my c square to the right side. So how it will look like, it will be 2ab cosine c equals to a square plus b square minus c square. Okay, next I will bring my 2ab over. Okay, so it will be cosine c equals to a square plus b square minus c square over 2ab. Okay, let me just shift them a little bit so that I have more space later. Okay, lastly, I am looking for angle C. So C will be equals to cosine inverse. So I'm bringing my cosine to the other side. Okay, what I will have is cosine inverse a square plus b square minus c square over 2ab. Okay, so either you remember the formula below to find the angle, or you can just change it. Okay, once you actually remember a little bit, you can actually jump from the first step straight away to the second last step, and then from here you can jump to your final step. Okay, but for now I just show every step so that it's easier for you to follow. Okay, so now I substitute everything in. Okay, C equals to cosine inverse a value of A, which is 15 square, plus B square. AB will be 24 square minus C square will be 21 square, whole thing over 2AB. So it's 2 times 15 times 24. Okay, now I just have to type the whole thing into my calculator, and I will get exactly 60 degrees. Okay, so 60 degrees is just to find C, but I want to find the bearing of Z from N. So I will have to do a final step of 180 degrees minus 60 degree, which will give me a bearing of 120 degree. Okay. Next step. Calculate the area of triangle XYZ. Okay, this one we already recapped in the previous question. The area of triangle equals to half AB sine C. Okay, so half A will be 15, B will be 24, C we already find it in the previous part, it will be 60 degrees, which equals to, when I type it in calculator, I get 155.88. I round off, it will be 156 meter square. Okay, moving on to practice question 1. Okay, let me make this pin here smaller slightly. Okay, house B is 400 meter due south of shop A. So what does that mean? So house B is just towards the south of A. Okay, this one can be seen on the right side. Okay, so the bearing of cafe C are 115 degree and 0.41 degree from A and B respectively. So what does it mean? Let me break down into two smaller parts so it's easier for you to see. So bearing of C from A is 115 degree. Bearing of C from B is 41 degree. Okay, let me erase all this working first. So what does it mean? So bearing of C from A, so I go to A first. I draw my north line. And then I go clockwise all the way until C. Okay, they are saying that this is 115 degree. Okay, and then actually I know that this top is 45 degree. So over here it will be just 115 minus 45 degree. Okay, so this will be 115 minus 90 degree. So this is 35 degree. Okay, or actually I can just find angle CAB. Okay, so this one angle CAB equals to 180 degree minus 115 degree, which equals to 65 degree. Okay, so this one is just adjacent angle on a straight line. Okay, so I'll write down this is 65 degree. What else can I find? Okay, for now we just leave it as that. I will go to my other piece of info. So bearing of C from B. So from B, okay, I can find this angle. This is my 41 degree. Okay, so now I have these 2 degree already. I can find also my angle of ACB. Okay, angle ACB equals to 180 degree minus 65 degree minus 41 degree. Then this will give me 74 degrees. Okay, so I just write down whatever I know first. 74 degree. Okay, find the distance of BC. So where is BC? Okay, BC is this one. I will highlight in green color. Okay, so I know I can't really use Picasso because there's no right angle triangle. Okay, so out of this one, I have 3 angles and 1 side. Okay, so since I only have 1 side, so I can't really use my cosine rule anymore. I have to use sine rule. Okay, actually, whenever you can use sine rule, just use sine rule. It's a lot easier to deal with. Okay, so if you look at the top right again, let me expand it slightly bigger. So do you see that I have 2 sides and 1 angle appearing for both? So actually, if you get 2 sides and 1 angle, I would recommend you to use sine rule. Okay, or at least I prefer to use sine rule because it's a lot easier than using cosine rule. Okay, back to the question. Okay, same thing. I'll put my unknown at the top left. So the one I want to find. Then the corresponding angle to BC is 65 degree. So I'll put sine 65 equals to 400. Okay, this is the only other side I know. Over is corresponding angle, so it'll be sine 74 degrees. Okay, same thing. I bring my sine 65 to the other side. And what I will get is BC equals to 400 sine 65, or let me write it slightly different. Yeah, it is the same thing. Sine 65. Yeah, I type this into my calculator. I get 377.1325. Okay, I round off. It will be equals to 377 meters. Okay, this is 3 SF. Okay, moving on to part B. They want me to find the shortest distance. Okay, when I want to find the shortest distance, it is always the one that cuts directly from the line and have a 90 degree. Okay, this is the shortest possible distance. Okay, so now I'm drawing the one in purple. Okay, so let me redraw the triangle below without having all the extra things inside. Okay, so I have this one now. Okay, let me label this part over here as D. Okay, so when I draw the bottom triangle, it will look like this. D, C, B. Okay, the bottom is 41 degree. So I'll put 41 degree. Over here is a right angle. What else do I know? Okay, BC is actually 377.1325. Okay, we found this in part A. So find the shortest distance. So I have a degree, I have a number, but in this case I have a right angle. Okay, so this is a right angle triangle. I can just use my Tokasu. So I have a I have a hypotenuse. I want to find DC, which is my shortest distance. So this is actually my opposite. Okay, so I have O and H. I will use sine. So sine 41 equals to DC is the one that I'm finding. And then hypotenuse is 377.1325. Okay, I bring my denominator to the other side. I get DC equals to 377.1325 sine 41. Okay, so this will give me 247.42. Okay, I round off. It'll be 247 meter. It's 3 SF. Okay. The next part, I think is common. Like it come out quite regularly, but it's slightly hard. Okay. So before we carry on, let me just take a screenshot of this so that I don't have to keep scrolling up and down. Okay. So let me carry on. So D is a point such that ADBC is a parallelogram. Find the bearing of D from B. Okay, usually when they name any shape, okay, is always in one direction. So AD BC means that this extra point is in between A and B. Okay, so in this case, it will be somewhere around here. So parallelogram. Okay, I don't need to be so exact. So I will just link it up. Okay, let me remove this D. Okay, so this D is actually over here. Okay, I know I draw it slightly off, but actually these two will be parallel because it's a parallelogram. Okay, and then these two will be a parallel. Okay, I want to find the bearing of D from B. Okay, I go to B. I already have my north line over there. I will go one full round until I find D. Okay, so how do I find this angle? Actually, since I have parallelogram, so I know somewhere I can use my tree property. Okay, but I will always prefer to use alternate angle because it's a lot easier. So in this case, I can actually form a Z shape over here. Okay, do you see? So with this Z shape, I know that angle DBA is actually 65 degree. Okay, so I write my working down. So to find the bearing, it's just 360 degree minus 65 degree, which equals to 295 degree. Okay. Okay. And then I'm gonna skip the next few questions. All these are very simple practice question. Can try it by yourself. Okay. Example. Okay. All of them is example 2. But the last one, take note that they want to find the bearing of O from P. Okay. So now it is from P. The others was from O. Okay. So just take note of that. Okay. This one also simple. You can try it by yourself just as a practice so that you get used to the wording. Okay, move on. I'll go with example 3, the last example. Okay, now we are like 47 minutes in. Okay, so example 3. ABC are 3 shops such that B is due east of A. Okay, so let me just write down, draw it into picture first. So I have shop A. Okay, so let's say here is A, and then this is north. Okay, for those of you who don't know what are the direction of compass, okay, let me just draw. So a compass, how I remember the directions. So let's say the front is north. Okay, the other side will definitely be south. How do I know where is east, where is west? Okay, how I remember is you must always be able to form the word B. Okay, so west is on the left, east is on the right. Okay, so B is due east of A. So B is the east side of A. Okay, let me draw. So this is 800 meter. Okay, the bearing of C from A, okay, is 132. So this is 90. So it's around here. Okay, it's not very exact. Okay, but I know it's around here. Okay, the bearing of C from B. Okay, let me go to B. I'll draw my north line. is 210. So 210 is more than 180 degree. So I know it is more than a straight line. So I'll draw roughly. Maybe over here. Yeah, I know this is 180. So I have to go for another 30 more degrees. So let's say around here. Okay, now I just have to connect. Okay, this one also. Let me just draw. Okay, so I know C should be somewhere around here. Okay, so this is my C. Okay, now that they give me all this bearing, this is 132, so this is 32 degree. Oh, sorry, this is 30 degrees. So I know actually this is a right angle, so I can find the value of this. Okay, this is 60 degrees. Okay, I also know this is 90 degree, so I can find this angle inside BAC. It's actually just 42 degree. How I get 42 is just 132 minus 90 degree. Okay, so with this, I can actually find my angle of ACB equals to 180 degree minus 60 degree minus 42 degree, which equals to 78 degrees. So I write down what I know first. This is 78 degrees. Okay, find the distance of AC. Okay, AC. This one highlighted in yellow. Okay. So I have three angles. I have one side. The only thing that I can use is my sine rule. Okay. So AC over its corresponding angle. So now is sine 60 equals to the only other side I have over its corresponding angle, which is sine 78. Okay. When I bring my sine 60 over, it will be 800 sine 60 over sine 78. Okay. When I type this into calculator, give me 708.298, and then I round off to 708 meter. This is 3 SF. Okay. Next one, part B. A straight path links A to B. Find the shortest distance from C to path AB. Okay. So let me copy paste this below. Okay, remember shortest distance, I will always have a right angle on the straight line. Okay, and then I will draw straight to point C. Okay, with this, let's say I use the triangle that is green color. Okay, why I use the triangle with green color? Because I already have the sides from my previous part. Okay, so previous part, this is 708.298. So now I have the side, I have the angle of 42 degree. Can just use my Tokaso. Okay, so I will just let O be the point on B with shortest distance to C. Okay, so it's actually over here. So sine BAC. Okay, so I'm using this angle over here, angle 42 degree. Okay, I know that I can use my torcaso. So opposite. Okay, wait, give me a. Okay, moving on to part B. Okay, the last part of this paper. Okay, they want to find the shortest distance from C to the path AB. Okay, let me just paste the figure we have above. So from C to path AB, shortest distance is over here. Okay, the one in purple. Over here will be a right angle. Okay, remember shortest distance is always a right angle. Okay, and then let me name this as O. Okay, so let the shortest distance from C to AB be O. Okay, so since I have a right angle triangle, okay, I'll focus on just the green triangle. Okay, I have two right angle triangle actually, but I will use the green one. Okay, why I'll use the green one? Because from the previous part, I found a side already. So it'll be 708.298. Okay, I found this hypotenuse side already. So this is actually my H. Okay, over here will be my letter O. So I can use my torcaso. I have O and H, I use sine. Okay, so sine angle BAC. So BAC is my 42 degrees equals to O over my hypotenuse. So in this case, it will be AC. So let me substitute everything inside. There will be 42 degree equals to O. So O is the one I'm finding over AC 708.298. Okay, O equals to 708.298 multiplied by sine 42. It will give me 473.9438. Okay, when I run out to 3SF, is 474 meters. Okay, that's it for this topic. Okay, just to summarize a little bit. Okay, some pointers to know. Bearing is always 3 digit. Okay, and 1 decimal if you need. If not, can just ignore the decimal. Okay, and the step to solve your question, always find out where it is from. Very important. Okay, draw the north line. This is just to remind you, because there are some cases where the north might not be pointing up, but all the example that the school gave so far, the north is pointing straight up. Okay, there will be cases where they will trick you and give you a north that points other direction. Okay, last but not least, always go in clockwise. If not, that's it for this topic.